All right, we're going to go over this progress check on inverse functions and transformations. So let's walk through each question. It says determine the domain and range of the function. So there's a couple of things to notice here. First off, there's a reflection over the x-axis. So that's going to change my range a little bit. Also notice that there is a b value here that has not been factored out. So I'm going to factor out the 2, which makes this one 3 over 2 under my square root. So that's where my starting point is for my domain. So this graph has moved to the right 1.5 spaces, up 1, and it's reflected over the x-axis. So my domain is going to go from positive 3 over 2 to infinity. And my range, because it was reflected, is going to go from negative infinity up to 1. And make sure you have brackets on the ends of those intervals. All right, the next one. Given this function, what is the minimum value of the function? So notice in the square root, I've got a reflection over the y-axis. So I'm going to factor that out. So I know that my graph has reflected over the y-axis. It moved to the right 2 and down 13. So it's going this way. So this point right here is 2, negative 13. So the question is, what is the minimum value? It's negative 13. All right, the next one, what is the domain? So the domain is going to be from this value to infinity because it's not a reflection. So from 2c to infinity, and the bracket should be on the 2c. Now this one caused a lot of trouble, so let's look carefully at this one so that you're ready for something like this should it occur on your test. Let's take the original function, and we're going to factor out that b value of 2, and now it says x plus 3, and then minus 1. So this is a cube root function, and that the key point where it's kind of in the middle is left 3, down 1. So it's at negative 3, negative 1. And it does the cube root thing that it does. This is negative 3, negative 1. Now let's apply the transformations. The first one is it's reflected over the x-axis. So if I reflect this over the x-axis, now I'm at negative 3, positive 1. And my graph is looking like this. From here, you have to do the reflection first. I'm going to go to the 3 units left. So if I'm at negative 3, 1, and I go 3 units to the left, I'm now at negative 6. And then I'm going to go 2 units up. I was at 1. Now I'm going to go 2 units up. And so now I'm at 3. So those are the changes that were made. So now my equation, I know it was a reflection. It's still a cube root. It's still got that b value of 2. But now I've moved to the left 6. And then up 3. So when I distribute in here, I get 2x plus 12, and then I've moved up 3. So you have to be careful. You reflect it first, and then you make the rest of the transformations. So don't just go, oh, the original equation, or 3 left, plus 3, 2 up, plus 2. Or if you don't account for this reflection first, you don't have the right points to start with. So be very careful there. This one says write the equation of f inverse of x given f of x. So first off, this is the notation for inverse. So to find the inverse, we're going to switch x and y, and then we're going to solve for y. Also notice the domain has been restricted to x is less than or equal to 5. So that means of this parabola, I want the left side, which means for the inverse, I want the negative side. We'll see how that works. Switch x and y. So x equals -2, y minus 5 squared, minus 1. So remember, peel everything away one piece at a time. First, I'm going to add the 1. X plus 1 equals. Now I'm going to divide by -2. X plus 1 over -2 equals y minus 5 squared. Now to undo the squared, I'm going to take the square root of both sides. Make sure that your entire fraction is under the square root. And this is the place where we introduced a square root, so we normally put plus or minus. However, because of this restriction, they told me I only want the negative side. I don't want the positive because they told me I wanted just the left side, which reflects to the bottom. So now I have negative square root of x plus 1 over -2 equals y minus 5. So all I have left to do is add 5 to both sides. And I've got negative x plus 1 over -2 under the square root plus 5. And that is my inverse. So there's lots of little details to be careful of there. Make sure your entire fraction was under the square root, and make sure you chose the negative side of the graph because they restricted the domain to the left side of the function. That means we took the bottom, the negative side of the inverse. So in the next one, they want us to sketch the graph of the inverse given this. So there's some ways you can do that. First off, this is a square root function, and I know it went left 4 and up 1. So I know it starts over here. Left 4, up 1. So if we calculate the inverse, remember we switched the x and the y. So I'm going to subtract 1. And then I'm going to square both sides, x minus 1 squared. And then I'm going to subtract 4. So there's my inverse. One of the characteristics of the inverse is that the x's and y's are switched. So in my original, it started at left 4, up 1. Look what's happening here. This one went right 1 and down 4. So if I go right 1 and down 4, here I am. Now this is a quadratic function, but up here, because it's a square root function, it's only this portion. It's just the top side. So the inverse is just the right side, where x is greater than or equal to 1. So that may not be the exact points, but that's the idea. It's half of a parabola, but it's the right side of the parabola because that was a positive square root. All right, on this one, you were asked to use composition of functions. That's where we plug g of x into f of x to see if it equals x. And then we plug f of x into g of x to see if it equals x. If both of those things are true, they are inverses of each other. If both of these are not true, they're not inverses of each other. So let's see how that works. So for the first one, I'm going to do f of g of x. So I'm going to take this g of x equation and plug it in for x. So I've got 4, and then I've got all of this, negative 16 plus x over 4 plus 16. The only thing I did was I substituted this in place of x. Now when I simplify this, first thing I notice is the 4's cancel out. So that leaves me with negative 16 plus x plus 16. Well, now negative 16 plus 16 cancels out, and that equals x. That's half of my task. Now I'm going to try it the other way. I'm going to check to see if g of f of x will simplify down to x. So this time I'm going to plug 4x plus 16 in place of this x. So negative 16 plus all of this in place of x over 4. So we start to simplify. Negative 16 plus 16 cancels, and I get 4x over 4, which divides out to be x. So the answer here is yes, they are inverses of each other, because f of g of x equals x, and g of f of x equals x. All right, next up, same thing over here. We're going to plug one equation into the other and see if it simplifies to x. So let's start with this one. We're going to put this in place of x. So negative square root of x minus 4 squared plus 4. So when you square a square root, you get just what was inside of it. So that looks like it worked. Now we have to test it the other way to see if the other way works as well. Remember, they both have to work to be inverses. So this time I'm going to plug this answer in over here. So negative square root x squared plus 4 minus 4. And we're going to simplify that. So I notice that 4 minus 4 cancels, and I've got negative square root of x squared. Well, when you square root something squared, you just get the number inside. And wait a minute, those are not equal. This does not equal x. So they are not inverses of each other, because they both have to equal x. All right, next up, list the transformations, fill the tables, and so on. So the parent function of this is f of x equals the square root of x. So our square root function starts with 0, 0, 1, 1, 4, 2, 9, 3. The transformations, well, there's a b value that needs to be factored out. Don't forget that part. And this is what it leaves me. When I factor out this negative, I'm left with x minus 2. So my transformations are a reflection over the y-axis, 2 to the right, and 1 down. So when I put these into my transformation rule, I've got a reflection and to the right 2, and then down 1. So we plug our numbers in for the x's. 0 plus 2, negative 1 plus 2, negative 4 plus 2, negative 9 plus 2. And for my y's, 0 minus 1, 1 minus 1, 2 minus 1, 3 minus 1. Now we can graph 2, negative 1, 1, 0, negative 2, 1, and 1, 2, 3, 4, 5, 6, 7, 2. There is our graph. Our domain, because of the reflection, goes from negative infinity until 2, because that's the furthest x value. And my range from bottom to top starts at negative 1 and goes on to infinity. All right, 2 more. This graph is horizontally compressed by a scale factor of 1/4. That's a B value. Shifted up 5, that's your D. Reflected across the y-axis, also a B value. What's the equation? So don't forget when you're writing an equation to put y equals or f of x equals. So I know I don't have any a values, so we're just going to stick with our cube root. But I do have a b value, so it's a reflection, so that's negative. Now compressed by a scale factor of 1/4, remember this is opposite land. So a horizontal compression by 1/4 gets a 4. And the up 5, I'm going to close my square root and put my plus 5 out here. That would be the equation that meets those standards. One more, find the inverse. So again, switch the x and the y, and then solve for the y. So x equals y plus 3 over 2 squared minus 1. I'm going to add 1 to both sides. And now I'm going to square root both sides. Now, with me introducing a square root, I'm supposed to do plus or minus. Notice my restrictions. This is the right side of the graph, which means it's going to be the top or the positive side of the inverse. So I don't want the plus or minus, I just want the plus. I only use the minus if this had said less than or equal to. So now I have the square root of x plus 1 equals y plus 3 divided by 2. I'm going to multiply by 2. And then I'm going to subtract the 3. Make sure when you write this that your 3, your minus 3, is clearly outside of the radical, or it means something completely different. And that is your inverse. You don't need to state a restriction on it because of the nature of the square root, it's already restricted. But because of this restriction, we knew out of the plus or minus, we chose the positive side because it said greater than. I hope this was helpful.